Hopefully that's what's happened. So I'm going to have a very quick spiel on tally data and what was referred to as baseline data, or we internally at least refer to as what we call generic data. And this essentially means the data that is to represent practice or materials sort of on average within the industry. So when a person uses Tally, this is the experience that they have. This is how they see the software. And obviously data is a big part of what you're looking at here, because there's the data, of course, in the Revit model, but there is quite a bit of information on the back end to basically create that life cycle assessment. And the data that we're really talking about right now is the data that attributes the environmental impact to the particular materials in your model. So when we talk about data, this is essentially the context in which we're talking about life cycle assessment data. This is the information that pertains to the materials, energy, and water that are the inputs into the system. And then in that system, you're going to have a variety of processes that will be occurring. So you have manufacturing processes, construction, use, end of life, and we call module D, which is reuse, recovery, recycling. And then out of that system, you're going to have a variety of emissions. Some of those things are good, some of the things are bad, but there are going to be emissions to the system. What's interesting about this is that data actually comes into play throughout every single one of these components. So I'm going to take a minute here and run you through what I mean by that. One of the first things is, let me close out this, is that when we talk about materials, that's one of the first inputs there. We need to understand how much materials that one has, and that's actually a big part of the data picture. So we have to create essentially a calculation method for quantifying materials that has, from a generic data perspective, a mechanism by which we're able to quantify stuff. And sometimes it's quantified by instance, like how many nails do you have on average in, say, a type of panel. A means of quantifying thickness for a particular type of panel. Some things are done volumetrically, so how big is something? Like, if you were to fill with water, how much would it take up? What is the sectional area of something? So if you were to cut it in half, what's the area of that? And then you can combine that, say, with length to be able to determine a quantity. And then what is the perimeter for certain elements? And this is all because these things are typically modeled in Revit, so we have to create a database that for certain materials calculates these things. And then for everything, you have to have a density figure. You have to have a essentially a mechanism for also calculating or assuming what materials will not be present in your Revit model. So we call these non-Revit model materials. We actually have to have an additional database of generic things that are associated with assemblies. And so that those can be also included in your assessment as opposed to being modeled in Revit. In the context of construction distance, we have to use that material quantity that we just generated to understand how far something actually travels. How much does that weigh? Because that obviously is the predominant factor when considering travel distance and impacts resulting from that. In the context of use, we have to understand for any given material, what's the replacement rate? So we have to have basically a generic replacement rate for certain types of materials, which is going to vary by application. If it's say paint or maybe a specialty coating, so on the inside of an assembly will never be replaced, but the same specialty coating on the exterior of the assembly might be replaced more frequently. We have to have a mechanism of understanding that in the context of data, which is also packaged in there. And then also replace with quantity. So, what components, I guess that's the idea of what components within assemblies are replaced, how frequently, and how will that differ from the assembly as a whole. Then you have end of life, essentially how much stuff goes into all these various waste streams. And then you also have to have module D, where once something goes into a waste stream, how much of those different pieces might be recovered or given back as a credit. So next thing, we also have to look at all the energy and water inputs into a particular material. So we have to understand, okay, for water, energy, other types of inputs, for that's actually rolled into, we call it the primary data source for our material for the manufacturing stage. That's the information that's really provided to us by ThinkStep, and it's a key part of what they do. And that information, of course, will then carry over into some of these other stages as well. So in the context of construction, we also have to, from them, get primary data about how much energy is used for various types of travel modes, but we also need to have actually how far something is going to be traveling during construction on average. The energy that's associated with each one of those travel modes, and of course, plus the distance, you get a better sense of the overall impact. And then also in the context of construction, we have the capacity for people to input non-material impacts related to construction energy and construction water, very specific for those or that one module. That means then that we also have to have generic data for grid and for, say, national level diesel for the impacts associated with that piece as well, which is another piece of generic information that we have. Then operational energy. You have the operational energy requirements. We have a grid energy data set for all over the US, much of the world, as well as a thermal energy data set, similarly for much of the world, that's provided by the International Information Administration. And then end of life, that's actually done for essentially by material category. So certain metals, say like all copper, will typically be treated the same way in end of life and have the same recovery scenarios. So that gets to be shared among multiple entries. But that's something that is created for us by ThinkStep. And there's data sets that they reference in order to create that. Then you have module D, recovery burdens and credits. So understanding what is the energy that's typically used or actually created during the recovery process or the recycling process, because recycling isn't a zero energy event. It may come out as a net positive, but it still takes energy to go through that process. So when we talk about all of this data together, in Tally, it is created using one software, Gabby, in version 8.5. And it's also using databases provided by Gabby, their 2018 LCI databases. And this is true for every single entry in our software. Similarly, it's all created by one program operator running that software, and that's Sphera. The idea being is if you have one entity using one software, one type of database, and one program operator, is that you're able to ensure that there is a consistency of decision-making, tool assumptions, tool capabilities, things like that, cutoff points, so that your data can really be compared across all entries. So anything that has an equivalent functional unit can be compared, even if it's in wildly disparate materials, which would not be the case if you're looking at, say, EPDs. Some of the data sources that we have that are either directly from that database provided by Gabby, or alternatively are reprocessed in Gabby using their own databases, but perhaps follow some of the same material flows and inputs, are manufactured EPDs, industry average EPDs. This is something that's actually quite common for there to be industry average EPDs. And then fully custom entries that are created by Gabby for things maybe that just don't exist anywhere else, which is not uncommon at all. There's actually quite a few materials where it's quite difficult to find. There are no manufacturer industry-specific EPDs. As far as data sources for travel mode and distance, this is something that the government, US government, actually tracks. So we use the 2012 Commodity Flow Survey. In there, they have basically travel distance by type of mode for all materials inside and coming to the US, which is a pretty remarkable data set. And that's what we use as an average that could then be adjusted by the user if they so choose. Energy comes from regional data sets provided by Gabby that reflect US average diesel and water energy. That's the operational energy, similarly, regional data sets. And then end of life is actually quite challenging. A lot of people always want to have their own end of life scenarios, but we actually use what's just average or generic for the US. And that's provided by a survey that's referred to, or a model rather, referred to as the WARM model, that is generated by the US EPA. And that looks at the various waste streams, particularly for, includes construction materials. So you're able to determine where they go, how much gets landfilled, how much gets recycled. And we use those percentages when it comes to the end-of-life scenarios in Tally, including, say, the various recovery streams in Module D. And then as far as recovery credits and burdens, that's all modeled by Gabby in their software. So that's where that particular data piece comes from, but the allocation would come from the WARM survey. So that's just, I guess, a very quick, I was told to give a 5 minutes intro into where, I guess it was a little over, but where all the data comes together. So when you use Tally and you think about like, where are all the pieces that are happening on the back end, that gives you a peek into sort of the layers of nested complexity and sort of overlapping web of information that's required to, say, in this case, just determine what is a brick wall and run that life cycle assessment.